My name is Thomas Cropton, and in this series of enablement videos I will show you how to create custom dashboards based on use cases from the field. Out of the box, vRealize Operations provides a wide range of different dashboards. Those dashboards are accessible through the Getting Started page. The Getting Started page gives a quick way to access all dashboards grouped by their purpose, like for example capacity, troubleshooting, or performance. On this page, you are one click away from the VMware Sample Exchange. The VMware Sample Exchange is a real treasure trove full of different dashboards created by the community and for the community. Another way to access all dashboards is using the Dashboards menu. Through this way, you have access to, for example, dashboards provided by another solutions. As a recap, you can access all dashboards using the Getting Started page and then drilling down into the area of your interest, or just clicking on the Dashboards menu and typing in part of the dashboard name so you can find the dashboard you are interested in. Like for example this one for the virtual machine configuration. Out-of-the-box or predefined dashboards are delivered as part of the solution itself within the native management packs like vSphere one or the vRealize one, or they are being delivered together with the added management packs, like for example the management packs coming with the True Visibility Suite. With the advanced edition of vRealize Operations, you have the ability to create your own custom dashboards or clone and adjust existing dashboards to better meet your requirements. Let's open a dashboard and check the components of a dashboard and how they work together. Dashboards consists of widgets, which are placed on a canvas. Widgets may interact with each other, providing data from one widget to the other widget. In this example, the data center selected in a left widget provides data to the widget right next to it. This interaction works will be explained in next few videos. The selected data center also drives the widget showing the list of virtual machines, and a selected virtual machine in this widget drives the data shown by the other widgets like the CPU usage or memory graph widgets. Here we can see how the interaction between widgets works. As long as we don't select any data center in a list of data centers, the dashboard remains basically empty. As soon as we select one of the data centers in the object list, the other widgets are populated with information coming from the object selected in this data center list. Now let us inspect a dashboard more closely and learn how we can influence the behavior of dashboard itself and the widgets within the dashboard. The first option we have here is the dashboard time. We can change the predefined 6 hours value to 1 hour, 24 hours, 7 days, or any other custom time range selected from the drop-down or specified using the From To options. All widgets within the dashboard configured with a dashboard time option will reflect the selected time range. Every widget designed to display metrics over a period of time has the option to either specify this time period within the widget or, using the dashboard time, retrieve the setting from the dashboard itself. Like in this one, we select the widget to have its own configuration. Now if we change the dashboard time, we see that this one widget remains the same. If we revert it back to from last hour to dashboard time, now when we change the dashboard time again, we see that this widget is again receiving the time period from the dashboard. Widgets have their own menu, which becomes visible once you hover over the title bar and click on this I like icon. Once selected, we see different options in the menu, and these options depend on the type of the widget. Let's check what's available for a list view. The Navigate button brings you to another dashboard. How to configure this navigation will be part of another video. It also allows you to open an integrated solution in context of the selected object. With the Actions menu option, you can run actions in context of the selected object. You can also set the time range for the selected widget. You can specify a rollup interval. What it is will be part of another video. And set the items per page to display. You can also reset the interaction between widgets. And finally, you can use the filter to specify the object you are interested in just by typing the name or part of the name of the object, and let the filter limit the list of objects to what you are looking for. After we have learned the basic concepts and terms behind dashboards, let's check what are the basic steps when creating dashboards. A click on Create Dashboard gives us an empty dashboard, and the empty area is called Canvas. The next general step is placing widgets on the canvas. Once we have added widgets to the dashboard, we need to configure the widgets. So step 3, configuring widgets. An optional but very often used step is configuring the interactions between widgets. And finally, we need to give the new dashboard a name and save it. In this video, you have learned how to find and access the predefined dashboards, the basic concepts like canvas, widgets, interactions, how to use the dashboard time, and how to use widgets menus. In this video, we will take a quick look at the most common widgets used in vRealize Operations dashboards. In a current version 8.4, vRealize Operations provides 43 different widgets. The object list is one of the most common widgets used in many dashboards. The object list provides a very easy way to limit a list of objects to certain types or objects having a certain property or metric, and this object list is very often the starting point of many dashboards. In this example, the object list provides a very quick way to select the data center out of all available data centers in this environment. One of the widely used widgets is the Scoreboard. A scoreboard is perfectly suitable for displaying KPIs of an object or other important metrics and properties. One of the most powerful widgets is the Heatmap. Heatmaps can help you display two related metrics or two dimensions of a situation. In this example, the Heatmap shows the data stores in a way where the size of the heatmap of the single parts of the heat map is driven by the total capacity of the data store, and the color is driven by the metric use capacity. Another commonly used widget is the health chart. The health chart widget is an excellent way to determine the health of an object by displaying color-coded metrics. The next widget I would like to introduce is the metric chart. The metric chart is the widget you use, for example, during a troubleshooting, where you need to drill down into an object and check certain metrics over time. Another very useful one is the Advanced Object Relationship widget. The Advanced Relationships widget perfectly displays relationships between objects monitored by vRealize Operations. It's perfect when you need to browse your inventory or you're doing a top-down or bottom-up analysis. Top N is another very powerful widget. The Top N widget is extremely helpful when you need to sort objects by a certain metric. And last but not least in this video, the Top Alerts widget. The Top Alerts widget is used to display, for example, the active alerts on a selected object. In this video, you have learned what are the most common used widgets and what are the use cases for widgets like Object List, Scoreboard, Heatmap and few more. Let's begin with an easy use case. I need a dashboard that will help me troubleshoot the performance issues I have with my VM, and it should also include insights into the most important KPIs. We start creating a new dashboard by going to the dashboard page, clicking on the dashboard menu and selecting Create Dashboard. Now we have an empty canvas and we can start placing widgets on the canvas. The first one will be an object list showing the VMs, and the second one will be a scoreboard showing the KPIs. First, we give the dashboard a new name, and having a custom prefix to all your custom content like dashboards, in my case tcopton, is a good way to help you find your content afterwards. We begin with the configuration of the widgets. So let's start with the object list. First, we will give it a name, and I tend to number the widgets to create a kind of a workflow going from one widget to the next one. For better usability, you can resize or maximize the widget. Every widget has a configuration section, and depending on the config itself and the type of a widget, it also might have input transformation, output filter, additional columns. All those different configuration elements will be covered in the upcoming videos of this series. We set this object list to auto refresh its content every 5 minutes, so the list of the VMs. The self provider will be set to on. That means that the information in this widget will be provided by the widget itself, and we don't select the first row here. For this object list widget, we select all as input data. So we are not limiting this widget to only certain objects. We just show everything, or the widget is able to show every object. The output filter is the configuration which is limiting the list to only virtual machines. So we select the object type and we go to virtual machine and select it. With the advanced option, we can limit the virtual machines we would like to see in this list to only virtual machines which are powered on. This is done through the advanced settings in the output filter. In this advanced filter, you can use metrics and properties or relationship of the object and exactly specify what objects, in that case virtual machines, you would like to see. Like, for example, virtual machines which are powered off and not powered on, or virtual machines which are exceeding a certain threshold for CPU usage or another metric. In this example, we don't configure any additional columns, and once click on Save, we have a working object list showing virtual machines, which are powered on. Now let's go to the scoreboard. First, we give it a name following the numbering we selected previously, and we set the auto refresh for the scoreboard to 5 minutes as well. The scoreboard will receive the input information, so the virtual machine it should show the information for, from the other widget. So in that case, the self provider will be set to off. Next, we specify how the values itself should be displayed, how many columns we would like to see, and if the boxes should be a fixed size or adjusted to the widget. The Scoreboard widget comes with different visual themes. You can select the theme from the drop-down menu, and you can specify what should be displayed within the box, like object name, metric name, metric unit, or if you would like to see the spark line, which shows you the value over the selected period of time. We don't change the input transformation as we would like to see the metrics for the virtual machine, and the virtual machine is exactly what the object list is providing to the scoreboard, so it's still the same object. Now, output data is exactly where we specify what we would like to see in the scoreboard. So here we select the virtual machine as the object to look up for metrics and properties. And for this virtual machine, we can select the metrics. We start with one metric to show in the scoreboard. With a double click on the metric, we can specify our own box label for this one, like for example CPU demand. We can also change the unit from auto to something else. In that case, % is okay, so it could be auto. And we have a color method. We can choose between none, symptom driven or custom. In that case, I select custom and specify the threshold for yellow, orange and red. Don't forget to click on update. To display some more KPIs for a selected virtual machine, we select additional metrics to display within this scoreboard. We have a metric already for CPU. Now we select something for memory and for virtual disk. Keep in mind, you just click once on the metric and then go to the next one and click once. A selected metric remains selected. Now we have those metrics added to our scoreboard. We do the same as before. We create our own box label for the metric. We select a unit if the auto unit is not exactly what we would like to see. And of course, we create a color method to showcase you the difference between a custom-driven color method and symptom-driven color method. We will set this one to symptom and the last one to none. In this use case for this scoreboard, we don't specify any output filter. We just leave it empty and click on save. To let the object list provide the data to the scoreboard, we need to wire them. To do this, you just click on show interaction and then connect the output of the select VM widget with the input of the check VM's scoreboard. So the one is an output, the other one is an input. Now, if you select a VM in the list, you will see the KPIs we specified for exactly that VM. Here we can see that the disk value box has no background as we set the color method to none. And we also see the white space as we configured the scoreboard widget to have 4 columns, but we have only 3 metrics. Let us change the configuration of the scoreboard widget and apply a column method based on thresholds to all the 3 metrics we already have. So we change it from symptom to custom and put in some meaningful threshold as value for yellow, orange and red background. The same for the virtual machine, virtual disks metric. We set it to custom and we set some other values to drive the color of the background for this particular box. Don't forget to click on update. If we now select a different virtual machine, then we see how the values change and also the color of the box changes accordingly. Let's see what happens when we change the configuration of the scoreboard from layout mode fixed view to layout mode fixed size. The fixed size mode allows us to specify the size of the single box, and it looks like this. We edit the scoreboard once again and we revert it back to fixed view, and to have 4 columns with data we add another metric. we select virtual machine, and for this example, we select a metric for the network packets dropped value. We configure the metric the same way as we did before. We provide a custom label for this one. We select a unit. We select the color method, and we specify the thresholds for the yellow, orange, and red color for the box. As always, don't forget to click on Update. Now we have 4 wonderful columns filled with data, and if we click on Save, we have our new custom dashboard ready to be consumed from the Dashboards menu. Now just click randomly on any VM and you will see that the KPI scoreboard shows the data we specified within the widget. Now let us quickly come back to the color method of a scoreboard and the symptom option, and let me explain what symptom is. In simple words, symptoms are conditions that indicate problems in your environment. So anytime VROps is collecting a metric or property, you can specify a symptom where the collected value is compared with what you specified in the symptom, and if that threshold is breached, then the symptom has a certain criticality, like warning, information, alert, etc. And using that symptom criticality can control the color method when symptom is specified as the color method in a scoreboard. Like in this example where the color of the total disk latency is derived from the triggered symptom. In this case, it is the critical one, which is more critical than the immediate. In this video, you have learned how to create a simple dashboard based on a real use case, how to place widgets on the canvas, how to configure widgets, including self-provider, input and output filters, color methods, and how the interaction between widgets works. In the previous video, we started with the following use case, and we ended up with a dashboard having an object list and a scoreboard showing the KPIs of the selected VM. In this video, we will learn how to extend that dashboard to help us troubleshoot a virtual machine. To do this, we will resize and rearrange the widgets on the dashboard and add another widget, the metric chart, to the dashboard to show the KPIs, the selected KPI, over a period of time. Okay, let's get started. We edit the dashboard. We resize the widgets, and as you can see, the widgets snap to the grid. Now we have enough free space to place the metric chart right next to the scoreboard. For better readability, we reconfigure the scoreboard widget and select 2 box columns, so now we can easier read the metric names. Now onto the metric chart widget configuration. As we get the metric from the scoreboard, the self-provider is off and the input transformation is self, so we consume just the metric we receive. There is no output data, no output configuration, and no output filter. We change the name of the widget and save it. In the next step, we need to configure the interaction between widgets. So the scoreboard widget sends the selected metric to the metric chart, and this time this is the orange colored connection between those widgets. So now anytime we click on a metric in the scoreboard, this metric is being sent to the metric chart and is added to this chart. So it's not replacing the previous metric, it is added to the metric to the display. And you can of course go and remove metrics from the metric chart. Since we have plenty of unused space on that dashboard, we edit it again and we resize the metric chart widget so it can display easily more than one selected metric. We save the dashboard and now we can proceed to the next step. In this step, we add the Advanced Object Relationship widget and the Top Alerts widget to the dashboard. We can also resize the widgets on the dashboard to better use the available space, and have a nice looking dashboard at the end. Now let's configure the object relationship widget. As always, first we rename the widget, the self-provider is off as we are receiving the object, and now the most important part, the inventory tree we select for this object relationship widget. So what is an inventory tree? As objects in vRops can have relationships to many different objects, an inventory tree provides an easy way to limit the display of those relationships to a certain tree or traversal spec. For example, focusing only on vSphere objects or only on NSX objects or any other context. Those inventory trees or traversal specs are provided by the vRops itself or are delivered together with the solutions or management packs. In our widget, we set the inventory tree to vSphere hosts and clusters, and we set the number of levels for children and parent objects to 5. As there is no additional configuration to this widget, we need to set up the interaction between the object list and the relationship widget. Now we can go to the object list, select a virtual machine, and the object relationship widget shows us all the related objects, like the ESXi host where the VM is running on, the vSphere cluster, the data center, the data store, etc. We can zoom in and zoom out and also fit the view to the size of the widget. If you would like to start the inventory tree at the vCenter level, for example, we go to the configuration and we change the parent depth to 3. Let's configure the top alerts widget. As always, we rename the widget. We specify what alerts we would like to see based on their impact. In our case, we would like to see all alerts. As we want to see the alerts for the selected object itself, we set the input transformation to self. And now, of course, we need to set up the interaction between the relationship widget and the alerts widget. Now, anytime we click on an object in the relationship widget, we will see the active alerts on exactly that object, like for example for the virtual machine or the selected cluster in here. And finally, we have a working VM troubleshooting dashboard where we can select a VM. We quickly see the KPIs for that VM. If we click on a KPI on a metric, we see that metric over time. We can select multiple metrics. We also see all the related objects to that VM. And if we click on one of those objects, we see the active alerts. In this video, you have learned how to improve the simple dashboard we have created in the previous video, how to resize and move widgets on the canvas, and how the relationships widget works based on object relationships and inventory trees. Let's work on a more complex scenario. The use case here is I need to troubleshoot VMs and ESXi hosts, including the underlying hardware. When you're creating a more complex dashboard, sometimes it's easier to start with pen and paper and have an idea how it should look like at the end. In this dashboard, I would like to have a list of my VMs which have CPU or memory contention. Once I have selected a VM, I would like to see a CPU usage chart and a memory usage chart for this VM. I also would like to see the ESXi host which is running that selected VM. And for this ESXi host, I would like to see the related objects, especially the hardware, the underlying hardware. And lastly, for the selected ESXi host, I would like to see the top 5 or top 10 VMs from the CPU, memory and disk perspective. Okay, let's start. First, we rename the dashboard and save it so we can easily find it again. Now we can place and resize and position all the widgets we specified in our pen and paper blueprint on the empty canvas. The easy part first, we edit the dashboard and we change the names of the widget within the dashboard to make it easier to find the right widget during the configuration in the next step. And I tend to use numbering as part of the widget name to have a kind of a workflow within the dashboard when consuming the dashboard at the end. Good, we start with the first widget, the object list. As always, we set the refresh content to be 5 minutes, and this one as the starting point is a self-provider, and we set the output filter to only show virtual machines in this widget. In advanced options, we select again virtual machine as we would like to limit the list to virtual machines having a certain metric, which in this case is CPU contention and memory contention, bridging a predefined threshold. For this use case, we just set 1% to have some more virtual machines in the list. As always, no additional columns. This time, before we start configuring all widgets, we will first set up the interactions between those widgets. The select VM object list will send the data to both metric charts widget 2 and 3, as well as to the object list showing the ESXi host widget number 4. The widget number 4, so the object list displaying the ESXi host, will send that host, that selected ESXi host, to the widgets number 5, 6, 7, and 8. As next step, we configure the CPU usage chart widget. We let refresh the content every 5 minutes automatically, the self-provider is off, and the input transformation itself, as we are getting the virtual machine as object and we would like to show the metrics of exactly the virtual machine object. Within the output data section, we specify the metric this chart should display. In this case, it's gonna be the CPU usage of the selected virtual machine. We can also specify thresholds for yellow, orange, and red horizontal lines the chart widget will display to help us determine if the current usage is breaching that value. If we now select a virtual machine in the object list, we see the chart showing us the CPU usage and the 3 defined threshold lines. We configure the memory chart widget the same way as we did it for the CPU chart, but of course using another metric. In this case, it's gonna be the memory consumption in %, and we set another values for the threshold lines displayed within the widget. Now, if we click on another virtual machine in the object list to refresh on the dashboard, we will see that now we have a chart CPU usage and a chart for memory consumed in %, including the threshold lines. As next step, we are going to configure the object list displaying the ESXi host running the VM we selected in the first step. In this widget, we set the input transformation to parent, as we would like to see the ESXi host in this list, and ESXi host object type is parent of a virtual machine object type. In this widget, we set the output filter configuration to object type host system, as we would like to see the host system in this object list, and as always there is no additional columns configuration. When we now click on a virtual machine, we see the corresponding ESXi host. Now we are ready to start the configuration of the new top N widgets. We switch on the refresh content option, we leave the bars count at 5, and we set the round decimals to 0. Now the most important part, we configure the metric analysis as we would like to see a metric, and we set it to top highest utilization here. As we would like to see the top 5 VMs for the selected host, we select children as the input transformation. Now we need to specify the metric we would like to display. We select as object type virtual machine, and as the metric we would like to display, we go for CPU usage in %. We specify the label to display and the unit. We could leave it at auto as % is the only one, but we select % here, and we specify the maximum to properly size the bars in the widget. The color method is here custom, as we would like to have different colors for different thresholds. For consistency, we can set the output filter to virtual machines. Now, if we click on the ESXi host in widget number 4, we see the top 5 CPU consumers listed from the highest one to the lowest one. The configuration of the top 5 memory consumers widget is basically the same as the one for the CPU consumers. The only difference is, of course, the metric we're using here. Here we're using the memory usage in % as in this example. When we now click on the ESXi host, we see that the top 5 memory consumers are also ordered from the highest one to the lowest one. And finally, the top 5 storage consumers. Again, the only difference is a different metric reflecting the total IOPS of a VM. Until now, we configured every widget with auto select first raw set to off, and that leads to an empty dashboard when it's selected for the first time. To change this, we set auto select first raw to on, and the object list will have the first item auto selected, and therefore having the other widgets populated with data. If we do this also for the widget number 4, then we have the dashboard automatically populated with data when we access it for the first time. Now we are going to configure the relationship widget. Essentially, we are specifying how many levels we are going up and down in a relationship chain coming from the object this widget is receiving to display another objects related to this one. Objects may have many relations between each other, and inventory trees are more or less kind of templates limiting the display of those relationships to certain object types. And with this setting, we now see vSphere objects related to the selected ESXi host. With the True Visibility Suite HPE Management Pack, for example, we can see HPE hardware objects related to the ESXi host. In this video, you have learned how to create a more complex dashboard starting with pen and paper and having the requirements of the use case in focus, and how to configure new widgets like metric chart and top N. In this video, you will learn how to use views within dashboards. A common use case is, for example, a dashboard providing a quick overview of the utilization of vSphere resources. We start with an empty canvas and plan our dashboard. At the top, we would like to have a list of clusters with their utilization-related most important metrics, and below that list, another list with ESXi hosts within the selected cluster, again as well with their most important utilization-related metrics. Good, so let's give the dashboard a new name and switch from the widgets to the available view types. First, we place 2 list views on the empty canvas as planned at the beginning, and we resize them to better use the available space. We begin with a very basic config. As always, as the first step, we rename the widget. If we now just save that widget, it will tell us that the configuration is invalid. That's because we did not specify any actual view in this widget. To shorten the list of available views, we set the filter to subject equals cluster compute resource for our use case. And now we select one of the views provided by VROps out of the box. After saving the widget, we see that there is still no data being displayed. As this view is basically the starting point in this dashboard, we need to set the self-provider option to on. Being self-provider, we need to specify the input data, so the objects being displayed in this view, and we do this with select objects, going to vCenter adapter, and now we could either select a certain cluster or a certain data center, or if you want to see all clusters within vSphere, we go to vSphere and vSphere World. vSphere World basically contains every single vSphere object managed by this VROps instance. The output data is still the same view we selected before, and now after saving the widget, we see clusters in the list view. Now we need to configure the other list view widget. And this time the self-provider is off, as we will receive the cluster from the previous view. The output data is again a predefined view. We can limit the list by setting the filter to subject equals host system, which is the ES6i host, and select one of the available views, which is appropriate for our use case. Now let's rename and save it. The last step of the configuration is the interaction between those two views. We connect the output of the first view with the input of the second view. Now we can save the dashboard, and anytime we select a cluster in a first view, this cluster is the input from the second view showing the ES6i host within that cluster. Up to this point we were using out-of-the-box views. If you would like to use your own custom view, you just edit it again. Go to the list. You can limit the list by setting a filter, for example to a prefix you are usually using as part of the name, and selecting the right view. If the new view needs more space to display all columns, we can easily resize the view widget. For the list of hosts, we follow the same procedure. We limit the list of views by setting the filter by object type and part of the name, so we can easily find our custom views, and we select the one we would like to use here. Let's resize the second view to make the appearance more consistent, save the dashboard, and now we can use it. Anytime we select a cluster, we see the utilization KPIs for the cluster, and we see also utilization KPIs for the hosts within the cluster. In this video, you have learned how to add and configure views within dashboards and how the self-provider option works for views. In this video, you will learn how to get more out of the widgets like Heatmap to make management using dashboards easier and most efficient, as well as how to make widget configurations reusable. In our use case, we would like to have a quick way to switch the view in a Heatmap from being CPU allocation focused to CPU demand to analyze the capacity. Like in this example, where we can switch the Heatmap for cluster remaining resources from capacity to time or VM. Okay, let us quickly check how to configure that feature. So what we would like to have is basically a list where we can select a data center, send that selected data center as input object to the Heatmap to view the cluster capacity from the CPU perspective, and have the ability to select between demand and allocation model, and then send that selected cluster to the both new widgets we learn in this video, the time remaining and the capacity remaining widget. I have already configured the object list and the necessary interactions so we can focus on the Heatmap. As usual, let us first rename the widget and set the input transformation to children, as we would like to see the children vSphere clusters for the selected data center in this Heatmap. To have different views on different metrics within one Heatmap, this widget provides the concept of configurations. Our first configuration will show us the remaining CPU capacity from the demand perspective using the corresponding metric. After giving the configuration a unique name, we can specify how to group the tiles within the Heatmap for this config. As the metric we are going to use in this Heatmap is not an instance metric, we set the mode to general. And now the most important part. First we need to specify the object type which is going to be displayed in the Heatmap, and then we need to tell the Heatmap how to size and how to color the single tiles. For both you can specify a metric, or leave it fixed. In our example, we set the size by value to be fixed, so every cluster in the selected data center will have the same size in a heatmap presentation, and the color for every cluster will be determined using the demand capacity remaining metric. Now we adjust the color for the minimum and the maximum value, and as the unit for CPU remaining capacity in the demand model is MHz, we need to adjust the maximum value to something meaningful for the particular environment. Now we can save the widget and we see the 3 clusters I have in this data center presented by the same size and having different colors according to the selected metric, the capacity remaining for CPU in megahertz. In our use case, we would like to have a quick way to switch the heat map from being demand driven to allocation. For this requirement, we simply add another configuration to the heat map. As in the first configuration, we need to specify the group by object type, as this is a required field. We set the actual object type to be displayed in the heat map to cluster compute resource, and the color by metric to this time allocation CPU remaining capacity with vCPU as the unit. As last step, we need to adjust the max value, as we are now using vCPUs as the unit for remaining capacity. Now we have an easy way to switch the heat map from demand to allocation driven context using the configuration drop-down menu. Now you are ready to add more configurations to that heat map to, for example, display the memory capacity remaining. Now let's learn how to make the configuration of several widgets a lot easier. Let's imagine you need to create a dashboard or multiple dashboards with different widgets showing the same set of metrics. One way to do this is to edit every single widget. Add your object type or object types you would like to show in this particular widget, add the metrics you would like to display, and probably edit every single metric in every single widget to change the label or to configure the color method. And now if you have to do this over and over again for multiple widgets with maybe more than 3 metrics, just because you would like to have another thresholds, you will be happy to hear that there is a quicker solution for that. The configuration files are the best way to create a reusable set of metric descriptions. First, we create a new configuration in the resource kind folder and give it a name. Now we need to select the metrics we would like to have in this configuration following the order: first adapter type, which is vCenter in our case, then the resource kind, which is host system in that case, and once we have selected the host system, we are presented with all the available metrics. You can select multiple metrics by clicking exactly once on every single metric you would like to have in this config. And finally, for every selected metric, you can change the label, the unit, and the thresholds for the color coding. And now, instead of selecting and configuring every single metric in every single widget, we can go and select our metric configuration to be used within the widgets. And now, if we need to change a metric label, unit, or threshold for the color coding, we only need to change one config file. In this video, you have learned how to create multiple views within one heat map, and how to create metric configurations to make widget config easier and reusable. In this video, you will learn how to export and import dashboards as well as the entire content in vRealize Operations. After you have created your custom dashboards, you may want to backup your work to an external location. The easiest way to do this is via the Manage Dashboards page. Here you can use the filter functionality to quickly find the dashboards you would like to export, select one or multiple dashboards, and then just export the selected content into a zip file. Now let's test the import. First, we delete one of the dashboards we exported in a previous step, and now we import the zip file containing the dashboards. We select rename for all those dashboards which are in the file and still in VROps. The import process may take some time to complete. Such dashboards will be imported into VROps having a new name with the index number at the end. The small wrench icon next to the name of a dashboard shows that the dashboard itself is being internally configured and it should disappear after a few seconds or minutes. Just refresh the page. Finally, we can see our deleted dashboard back in the system. Now, if you would like to export all the content you have in your vRealize operations, you go to Administration, Content Management, and here you can generate an export file containing everything like alert definitions, custom groups, dashboards, etc. That process can take several minutes to complete. Once finished, you can download a zip file. Now let's imagine we have lost few of our dashboards and we need them back. That's an easy task. We go to Content Management and import our zip file. As we would like to import only the dashboards we have lost, we select Skip Items. In case of conflicts, we select the zip file we created in a previous step and we start the import process. That process may take some minutes to complete. After the import has finished, the content is available again. In this video you have learned how to export and import single and multiple dashboards, as well as how to export and import the entire content in vRealize operations. In this video you will learn how to share your dashboards with other users and user groups. Now we have our custom dashboard and we would like to make it available for other users and groups. So what options do we have? The quickest and easiest way to share a dashboard with others is the Share Dashboard functionality within the dashboard. You have the choice between creating an auto-expiring link you can share with others, sending an email containing a also auto-expiring link, an iframe you can use to embed into other pages, sharing via AD or VIDM group, or just exporting the dashboard into a file. Okay, let us check how the URL sharing actually works. One click on the Copy Link button creates the link you are sharing with others. Now you can paste that URL into a browser and you will see that we don't need any login to use that shared dashboard. Another way of giving authorized users access to dashboards is through the Manage Dashboard Sharing functionality. The Manage Dashboard Sharing feature allows you to share dashboards with local VIDM or AD integrated user groups, as well as with any user logged in into vRealize operations and having sufficient permissions. In this example, you can see that I'm not sharing any dashboard with the engineering department. We are going to change it. You can use the filter to quickly find the dashboards you would like to share. Then you select the dashboards and simply drag and drop the selected dashboards onto the group you would like to share those dashboards with. Now we are logged in with an user account, which is member of the engineering group, and with that account we have access to both dashboards we have just shared. To stop sharing any dashboard with any group, you just go to Manage Dashboard Sharing, click on the group you would like to stop sharing with, select the dashboards you would like to move from sharing, and then click on Stop Sharing, and at the end on the Save button. When we now log in again with the same account as before, we see that both dashboards disappeared from the menu. In this video you have learned how to share dashboards using the URL sharing option with users without login permissions to vRealize operations, and how to share dashboards with vRealize operations users. In this video you will learn where to find more useful dashboards and other vRealize operations content. One of the sources is the vRealize operations sample exchange. You can get there directly from the Quick Start page. Or you go to the Getting Started page and click on More Dashboard Samples. On the Sample Exchange website you can set the filter to show only dashboards, select your dashboards you are interested in, see the preview and download the zip file. The VMware Code website is another way to access the Sample Exchange. Among plenty of different code samples here, you can search for dashboards, see their preview, see how to install the dashboard after downloading, and finally download the dashboard and import it into your vRealize operations.